Hey there, ladies and gentlemen. This is Collins here, and we're going to go through homework 2.5, which is a pretty short one because you did a whole bunch of it online and already have some feedback from that. So this is just really the staying sharp to, hey, keep you sharp. Hey, aptly named, right? So let's get to it. Complete the square box problem. So let's get to this one. The thing you have to keep in mind about the square box problem is that it is a pattern. So if we take two numbers on the side, the wings, if you will, and then you add them, you're going to get the number at the bottom. Conversely, if you take these two wing numbers and you multiply them, you should get the one at the top. So the question really is, well, what number do you want to use first? Do you find first? You want to find the 60 or do you want to find the 17? Now, just from experience, I can pass you a little bit of advice, and that advice is always to start with multiplication. Here's the reason why. If I have to think of two numbers that multiply to make a number, there's going to be very few numbers that actually do that. In fact, we can make a list. Like if we have to make the list of what we call the factors of 60, numbers that multiply together make 60, that's pretty short, right? We have 6 times 10. We can take 3 times, 20. We can take 2 times 30, right? And then like 1 times 60. So the point being, like we have a very, very short list that can actually accomplish what we need to accomplish, and there might be more. Those are just 4 that I ripped off right away. In fact, if I grab my calculator here, we could probably come up with some more. Calculator, just by doing some division. So like we can test some stuff out, like 60 divided by 4. 60 divided by 4. Okay, it's 15. So we get 4 and 15. So we have 1, 2, 3, 4. We haven't tried 5, so let's take 60 divided by 5, and we get 12. So 5 and 12 also are numbers that multiply together to make 60. Point being, if you were to start with the addition, you'd still be making a list. I mean, if you think of any number, like 5, you can think of a number that multiplies to 5 to get, or I'm sorry, adds to 5 to get 17 plus 12. Or let's say 10 plus 7 makes 17. 8 plus 9 makes 17. 17 plus 0 makes 17. So we can make this list forever. If we start with the multiplication, the list is going to be much, 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 much shorter, okay? So I would definitely always start with the multiplication. Here's a little happy face to help you remember. Boom. Okay. So now what we have to do is realize that since we have all these choices, the way we're going to make that choice is to look at the addition. We have to pick two numbers out of this list that we know multiply to make 60, that add also to 17. Well, 6 and 10 won't do it because they add to 16. That's 23. That's 32. That's 61. Oh, we're getting closer. That's 19. Hey, look at this guy. 5 and 12. 5 plus 12 happens to be 17, so that must be our answers. Positive 5 and positive 12. So again, it's about finding the multiplication first and then picking out of that list which one that does the addition. Okay, so each term of a sequence is 2 more than its previous term. If the third term is 8, find the first 5 terms of the sequence. Okay, so we have a number, the first term, which we don't know. Then we have the second term. Then we have 8 for the third term. Then we have another one. Then we have another one. So we have to fill in this list. And the only clue we've been given is that each term of the sequence is 2 more than the previous number. So what we're saying is that if I take 8 and then add 2, I get the next one, which is 10. Add 2 again and get 12. Now, we have to fill in all the first 5 terms, which means we actually have to go backwards. But luckily, you guys know about working backwards. If I add 2 going one way, subtract 2 going the other, that's a 2, Mr. Collins. And so that should carry here as well. So 8 minus 2 should give us a 6. Subtract 2 more, boom, we got a 4. So 4, 6, 8, 10, 12. In fact, if we step back and look at that, that seems to be a very reasonable sequence. So that's the first 5 terms. What two numbers have a sum of 17 and a difference of 1? So two numbers that add together to make 17 and subtract one from another to make 1. Well, again, this is all about thinking about the possibilities, but if there's only going to be one apart, I want to try to split 17 closest down the middle as I can. So 17, it doesn't split too evenly, but 17 is going to be 8.5. So that means my numbers are probably going to be 8 and 9. Okay, so just to kind of review how I did that, I took 17 and I tried to split it right in half because a difference of 1 means the numbers are very close to one another. So 8.5 is 17 divided by 2. And then since I need a difference of 1, I just went up and down a couple. Okay, so 17 and a difference of 3. Well, 8 and 9 give me a good starting point. So if I take 1 down from 8 and make it down to 7, okay, and then take 1 up from 9 and make it a 10, that's going to go ahead, that's actually going to give me the numbers I'm looking for. So to kind of think about how I did this, I already had a difference of 1 here, okay, between these two numbers. So I just went 1 more on either side. So I went another 1 on this side of 8 to go to 7, another 1 on this side of 9 to go to 10. So I had the 1 I was apart, and I added 1 more here and added 1 more here. That's going to be 3. So that should probably work again. So if I go 1 more, so I had 7, make that 6, and add 8, 9, 10, go 1 more, make it 11. 6 and 11 should be those. Okay, and I just explained my process as I was thinking about it, so I'm not going to explain it again. But basically, if I know I had a difference of 1, that means they're pretty close to being split evenly. So I thought, well, what splits 17 evenly? It's 8.5. But I need a whole difference of 1, so I went up and down just a little bit. Same thing with 3, same thing with 5. Womp, 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 womp. All right, search for patterns in the table. Then use patterns to complete the next rows of the table. So we have to be careful when we're using a table because we have to kind of evaluate both sides at the same time. Like we can definitely observe this goes up by 2, but we have to also observe simultaneously this goes up by 1. Okay, so then that's going to go up by 4. That's going to go up by 1. That's going to go up by 6. That's going to go up by 1. So if this pattern holds, we'll do left side first. That should be 5. That's going to be another plus 1. But check this out. 2, 4, 6. If this pattern is making sense, that should be 8, making that 20. So that should be 6 here again, another jump of 1. Jump here should be 2, 4, 6, 8, 10. Make that guy 30. And then make that 7, 2, 4, 6, 8, 10. Jump a 12, making that 42. Okay, so the pattern I used was actually twofold. I had to notice simultaneously that this side goes by 1, goes up by 1. At the same time, this goes up at an increasing rate of 2 more each time. Okay, it's actually not that different than some of the patterns we looked at, it's just above it. Let's talk about Roberto. He got a puppy from the shelter. It weighed 11 pounds. The puppy gained 40% of its original weight in the first month that Roberto had it. How much did the puppy weigh after the first month? Okay, well, first of all, we have to figure out how much it gained. So it started at 11 pounds. It gained 40%, and that's going to turn into a multiplication problem. 40% as a decimal is going to be 0.40 divided by 100. So 0.40. So this is going to tell us how much it's actually going to gain. So bringing out my handy-dandy calculator, I'll take 11 times 0.4. Ooh, 11 times 0.4 is 4.4. Okay, so that's going to be the amount gained. Okay. Now, this doesn't tell us that actually answers to a question because we want the puppy's weight. Well, he was 11 pounds, gained 4.4 pounds. That means he's a nice chunky 15.4 pounds. Okay, there is another way to do this. Okay, now I'm going to present that in a different color. He was 11 pounds, and then he's going to keep his 11 pounds. He's going to keep the 100% he had. Then he's going to gain 40 more percent. So he's going to gain 140%, which as a decimal is 1.40. So I multiply 11 times 1.40. Lo and behold, I get exactly 15.4. Check it on a calculator if you don't believe me. So we can do it a couple different ways. We can break it up into 2 problems where we figure out how much he gained and then add that to the original. We can also do that in a single step by acknowledging that he's going to keep 140% of what he was. 100 is what he has, 40% is what he's gaining, and that's what that represents, 140%. Well, okay, so we got to represent 1/4 and 3/4 by shading in the appropriate parts of each rectangle and then write them as a decimal and percentage. So let's do this in green. So 1/4, so we have to kind of understand what a fraction means. And the way to kind of interpret this is that this is 1 part out of 4 parts total that make the whole. Okay, so what I mean is if I take this square right here and divide it into 4 equal parts, well, that's not really equal, Mr. Collins. Womp, womp. And I shade in 1/4 of it, 1 part of the 4 parts that make up the whole. I've represented 1/4. So that's kind of what this means as well on this side. I still have the 4 parts that make up the entire thing, but in this case, I'm going to shade in 3 of them. Okay, so as a decimal, we can kind of come up with this a couple different ways. Primarily, you can just take 1 divided by 4 and end up with 0.25. Okay. Here, same idea, this is going to be 0.75. Color scheme, Mr. Collins, that's important. 0.75. Then as a percentage, we take that number and multiply it by 100. So if I take 0.25 times 100, so this is 1 divided by 4. So 0.25 times 100 is going to equal 25%. So in the same way on the right, where this was just 3 divided by 4 to make 0.75, if I take, let's see, 0.75 times 100, I get 75%. Okay, so that's what I got. That's the entire homework, actually. So I hope you guys were helped by this video. You guys did actually a really wonderful job in class today, so I want to thank you for that. And that's all I got. See you guys tomorrow.